Good day, everyone. I'm preparing here to solve some questions to review for the final exam. We'll begin with the absolute value equations. Remember that inside the absolute value, I may have a negative value or a positive value, and the absolute value is going to wash the sign. So in both of those cases, the solution would be just the positive quantity. So to solve this equation, I would end up having two equations. One of it is what if inside I have positive, and one of it is what if inside I have a negative value. Well, solve linear equation. We add a to the other side. That's going to be a 13. X is equal to 13 halves is one of the solutions. And in the other case, add a to the other side would be a 3, or x is equal to 3 halves is the other solution. You can check and see that both of them work. Absolute value inequality, when inside I have a whatever I have inside is supposed to be greater than 11. So that means I can have 12, let's say, because 12, the absolute value of 12 is greater than 11. Or may end up having negative 12 in the absolute value, because absolute value of negative 12 is also 12, which is also greater than 11. So if you look at the number line, solutions that are good for this equation, this inequality, would be numbers that are less than negative 11 and larger than 11. So that is a true statement. So I'm looking at this area right here. That means 2 minus 3x must be less than negative 11, or 2 minus 3x must be greater than 11. Solve those two inequalities. Subtract 2 from both sides. That's negative 13. Divide by negative 3. Well, remember, when we divide by a negative number, we flip the inequality. So that's going to be 13 thirds. The other inequality, subtract 2 from the other side. 11 minus 2 is 9. And then divide by negative 2. Wait, that's 3. Divide by negative 3 would give me, and again I'm going to flip the sign when I divide by negative, so less than negative 3. So x must be a number greater than 13 thirds and less than negative 3. So the solution should be from all those intervals. In interval notation, that's written as, so that's negative infinity, so from negative infinity to negative 3, and from 13 thirds to positive infinity. Notice that the negative 3 and the 13 thirds are not included because the sign was greater than, not equal. So I have this in parentheses. The other inequality with absolute value is 8x plus 9 to be less than or equal to 6. Well, that is, it's good to have a 5 because absolute value of 5 is 5, which is less or equal to 6. And it's also good to have negative 5 because absolute value of negative 5 is 5, so also less or equal to 6. So if you look at the number line, we are good for all the numbers between negative 6 and 6 can be solutions because absolute value of them would be less than 6. So how do we solve that? Well, we go 8x plus 9 must be a number between negative 6 and 6. We are going to subtract the 9 from all sides. That will be negative 15 to be less or equal to 8x less or equal to negative 3, and divide by 8. That will be negative 15 eighths and negative 3 eighths. So the solutions for x will be all the numbers between negative 15 eighths and negative 3 eighths. All those numbers in between. In interval notation, that's negative 15 eighths to negative 3 eighths. Notice that because of the equal sign, we'll have brackets around the answer. We'll continue with radical equation. So to solve for this radical, to cancel a radical, we need to square both sides of this equation. So we need to square both sides of this equation. And this radical and the square would cancel each other out. So we end up having x plus 3 is equal to x minus 3 squared. Well, x minus 3 squared, that's the same as x minus 3 times x minus 3. Or x plus 3 is equal to x squared minus 6x plus 9. Now that's a quadratic equation. We solve by moving all the terms to one side. I'm going to subtract x from both sides. I'm going to subtract the 3. And this equation we can solve by factoring. That will be x minus 6, x minus 1. The solution of these equations are x is equal to 6 and x is equal to 1. Since we had to square both sides, we might have added additional solutions, so we need to check first. Check by plugging 6 in the original problem. And we wonder if that's the case, that 6 plus 3 is equal to 6 minus 3. That square root of 9, is it equal to 3? And yes, that's a true statement, so we're going to circle that solution. And then x is equal to 1, if we plug in a 1 in the problem, wonder if that's a true statement. Well, is square root of 4 equal to negative 2? That's wrong statement, meaning x is equal to 1 is extraneous solution. So we only have one solution for this case. X is equal to 6. Next question is quadratic equation. We're going to solve this equation by completing the square. Complete square is made from, based on the formula, is made from a square and b square, and in the middle we have twice the first times the second term. So I have x square, which is my a square, so that's my x square, and then the second term is 4x, so that means plus 2 times x. This shows me that b is actually have to be 2. So I need to add 2 square to this problem to be able to complete the square. So 4x plus 2 square, which is 4. Well, I'm adding 4 to one side of the equations. I'm adding that 4, so I have to add it to both sides, not to change the problem. So I have to plus 4 to both sides. The complete square will be the first plus the second squared. So x plus 2 squared is equal to negative 16. Now we'll solve by taking square root of both sides, because square root is opposite operation of something powered by 2. So we're going to square root both sides. Notice that square root of x squared, those 2 cancel. However, the solution is absolute value of x plus 2, not just x plus 2, because like if we have square root of negative 2 squared, well, that's square root of 4, and if we don't put the absolute value, the answer would be just 2, not the negative 2 as required. So the solution would be both of those. It's actually going to be absolute value of whatever the answer was. So after squaring, we end up having here absolute value of x plus 2, which is equal to square root of negative 16. Well, square root of negative 16 is the same as square root of 1 times square root of negative 1 times square root of 16. Square root of 16 is 4, square root of negative 1 is I. So we end up having here 4i. We'll break this equation similarly to above to two problems. X plus 2 is equal to 4i, and x plus 2 is equal to negative 4i. Now, how we teach that? For shortcut, we skip this step. We sometimes skip this step, but we say, well, when we find square root, we always end up having two solutions, plus or minus square root of the answer. Now the first solution is negative 2 plus 4i, and the second solution is negative 2 minus 4i. So two solutions here. Logarithmic equation. To solve this logarithmic equation, we would combine those two terms to one logarithm by using the property logarithm of m plus logarithm base b of n is the same as one logarithm when we multiply the insides. So I'm going to multiply the insides here, keeping logarithm of 4. X times x minus 6 is equal to 2. Now we're going to use the property that logarithm base a of b is equal to c is exactly the same statement as a power by c is equal to b. So I'm going to start from that base. A is 4 in this case. 4 power by 2 is x times x minus 6. Let's see, 4 squared is 16. I'm going to distribute here. X squared minus 6x. Well, this quadratic equation, so we need to move all the terms to one side. X squared minus 6x minus 16 is equal to 0. See if we can, yeah, I think we can factor here. That's x minus 8, x plus 2. Negative 8 times 2 is negative 16. Negative 8 plus 2 is negative 6. Yes, that's correct. So we come up with two solutions. X is equal to 8 from the first factor and x is equal to negative 2 from the second factor. Well, remember that the domain of the logarithmic function is inside right here. I'm supposed to be having positive values, so we need to check. And logarithm base 4 of 8 plus logarithm base 4 of 8 minus 6 is good, because in both cases we'll have positive values inside the logarithm. So 8 is a solution. But if we attempt to put the negative inside, well, it's going to be negative 2, logarithm of negative 2, and you can check with your calculator, but that doesn't work. Logarithmic function only works with positive x values. In fact, if I sketch the logarithmic function equation graph, it's going to look like that. See how it only works on the positive side. Here, there is no negative values. So that negative 2 here is going to be again extraneous solution, and it's not a solution of the logarithmic equation. Solve this exponential equation. Well, the best way to solve the exponential equation is using the property that a power by x equals to a power by y, or that means x must be equal to y. So if I'm able to present both sides of this equation with the same base, I can drop the base and only compare the exponents. We'll recall that something power by 1 over a is the same as a power by negative 1. So this 3 is the same as 1/3 is the same as 3 power by negative 1. Also, 9 is the same as 3 squared. Now we're going to use the property that a power by n power by m is the same as multiplying the exponents. So that's the same as 3 power by negative 1 times 3x plus 6 is equal to 3 power or by 2x minus 5. Now that the bases are the same, we can scratch the bases and just compare the powers. Well, that's negative 3x minus 6 is the same as 2x minus 10. To solve, I'm gonna plus 3x to both sides and plus 10 to both sides. That's a 4 is equal to 5x, or the solution is x is equal to 4/5. Notice that I'm not checking every single question. The reason is the exponential function has domain of all real numbers. If I'm to graph exponential function, it looks like that. It's good for all the x values from negative to positive infinity. So provided that I work correctly, all x's are possible. Find the slope-intercept and the standard equation of the line that goes through the points 1, 8 and -2, -4. So one way to solve this problem is use the point-intercept form. Oops, that's times here. So to use this form, I need one of the points. So I may use the point x1 to be 1 and y1 to be 8. And then I need to find the slope. Well, the equation of the slope is y2 minus y1 divided by x2 minus x1. I'm going to plug in both points here. -4 minus 8 and -2 minus 1. The slope is -12 divided by -3, which means 4. Well, let's plug in that information. Y minus 8 is the slope 4, x minus 1. Y is equal to 4x minus 4, and I'm adding 8 to the other side, or y is equal to 4x plus 4. Another example, and I'm going to solve the other example with a different method. I'm going to use the slope-intercept form directly. That is the slope-intercept form. So I'm going to use one of the points, x to be -2 and y to be 1. I'm going to plug this in the equation. Of course, I need to find the slope also. So slope would be -17 minus 1 divided by 4 minus -2. That's -18 divided by 4 plus 2 is 6, so -3. So I'm plugging the points here and the slope. That's 1 is equal to -3, x is -2 plus b. 1 is 6 plus b, or b turns out to be 1 minus 6, which is -5. My final answer would be y minus 3x minus 5. Next question, graph the basic function using a dotted line. Graph the transform function using the solid line. Give the domain and the range of the transform function. Alright, so the basic function is absolute value of x. So y is equal to absolute value of x. And it's a v through the first and the second quadrant. Let's see what's done to this v. Well, that +1 here means that the function is moved -1 unit horizontally. So opposite of what we see. So the new vertex is going to be at -1. What else? Well, we have that -2 here. Oh, this -2 is going to be down 2 units. So the vertex we'll move down 2 units right here. Furthermore, the graph will be with a multiple of -1/2, meaning that -1/2 absolute value of x will have every time whatever is the solution is going to be divided by 2 and actually opposite sign. So instead of the graph going up, it's actually going to go down. Not only that, but whenever the graph is supposed to be 1, it's the solution will be divided by 2, so it's 1/2 of it. So let's clean that and make a beautiful graph here. And it's the graph would pass through that vertex, and the opening is going to be 1/2. I'm not doing it pretty. Here you go. So that's the graph, -1/2 of absolute value of x plus 1 minus 2 versus the graph of absolute value of x. What else do we need to do? We'll need to do, so let me write that down. So the negative sign is reflection. Over the x-axis, and also we have divide the y values by 2. Then I needed to do the domain and the range. Domain. I can see that domain is all real numbers from -infinity to +infinity because the graph doesn't have any interruptions. The range, well, it looks like the values start from -infinity and go all the way up to -2. So the range is -infinity to -2. -2 is included because the point -1, -2 is the point from the graph. Next equation, find the vertex, x-intercept, y-intercept, and sketch the graph. Well, this is graph of a parabola, and recall that equation of a parabola is in the form of ax minus h squared plus k, where hk is the vertex, and in this case the vertex is -1, 4. Remember that's negative h, so that plus 1 is -1. So the graph is gonna go through 1, 4, -1, 4. That's the vertex. That means there will be an axis of symmetry going through that vertex. So the vertex is -1, 4. Y-intercept. Y-intercept happens when x is equal to 0. So if we plug in x to be 0 in this equation, we have -2, 0 plus 1 squared plus 4. That's -2 plus 4 or 2. So the y-intercept is 0, 2. 0, 2. So that's the 2. That's the intercept. So here we have -1, 4. We have the 2. Since 2 is on the x-axis, which is on the y-axis 1 away, and the graph is symmetrical, that means the point Negative 2, 2 is also on the graph. X-intercepts. For x-intercepts, y value is equal to 0. Y value to be 0 means negative 2 x plus 1 squared plus 4 needs to be equal to 0. Solve this equation by subtracting 4 from both sides and then divide it by negative 2. Square root both sides. Remember that we're going to say x plus 1 is equal to plus or minus square root of 2. Then the x-intercepts are negative 1 plus square root of 2, and the other one would be negative 1 minus square root of 2, which that will be somewhere around 2.5. And that's how we graph it. Did we need to say anything else? No, but if they wanted me to say what is the domain, I would say, well, the domain of quadratic function is all real numbers. And the range, those are all the values from negative infinity to 4. And 4 is included because there is a point negative 1, 4 on the graph. Similar question. The vertex, as we said above, it's going to be negative 3, negative 2, to negative 3, negative 2. We have a vertical axis of symmetry through that point. Y-intercept, or when x is equal to 0, will be 3 squared minus 2, which is 7. So it's right here. That means 3 away we have another point. X-intercept, or when y is equal to 0, would be when x plus 3 squared minus 2 is equal to 0, or when x plus 3 squared is equal to 2. Square root both sides similarly to above. Would be plus and minus square root of 2, meaning one of the x-intercept would be negative 3 plus square root of 2, and the other one would be negative 3 minus square root of 2. Let's see, well, that's it's around 1.5, so negative 4.5. So somewhere right here, negative 4.5. That's going to be the negative 3 minus square root of 2. And somewhere here. I didn't make it very pretty. Like this. In this case, again, the domain would be our real numbers. In the range, this graph has the lowest point at negative 2, so start from negative 2 and goes to positive infinity. Find the intercepts, describe the end behavior and the behavior at the zeros using multiplicity. Let's see, the zeros would be all of the factors of the function equal to 0. So we need to make negative 3x to be equal to 0. We need to make x plus 1 to be equal to 0. We need to make x plus 2 equal to 0. So the zeros from here are 0, negative 1, and negative 2. So the zeros, 0, negative 1, and negative 2. X-intercept as ordered pair would be 0, 0, negative 1, 0, and negative 2, 0. Multiplicity means how many times this 0 is multiplied and look like x is powered by 1 every time. So multiplicity f1. When the multiplicity is odd, the graph crosses through the x-axis. And behavior, what is the behavior of this polynomial? Well, it looks like the power function of this polynomial is negative 3x. The largest term from the second multiple is x, and the largest multiple from the last multiple is x. So that's negative 3x cubed, meaning the polynomial would be decreasing as x increases. Y-intercept is when x is equal to 0. So I'm going to plug in x is equal to 0 in the equation. F of 0 is negative 3 times 0, 0 plus 1, 0 plus 2. And if we calculate all those, we will get 0, which, yes, I know 0, 0 is a point from the graph already. So 0, 0 is the y-intercept. So let's plug that information on the graph. Those are the points of intersection. The polynomial will start from above, go crosses at negative 2, then we'll flip around and cross through negative 1, then flip around and cross through 0. We'll continue towards negative infinity. Similar question. Let's find all the zeros. One of the zeros would come from x minus 2 squared is equal to 0, which means x minus 2 must be 0, or x is equal to 2. That's the first 0. Then we have x plus 1 to be 0, or x is negative 1, and x minus 3 to be 0, or x is 3. So we have all those 3 zeros. In ordered pair, that's 2, 0, negative 1, 0, and 3, 0. The first multiple is twice, so it has multiplicity of 2. When the multiplicity is even, the graph touches the x-axis. The other two multiplicities, or the other two zeros, have multiplicity of 1. So the graph crosses through them. What else? What's the end behavior? Oh, let's look at it. It looks like the first is, the first x is powered by 2. So the power function is x powered by 2, and then the other x is powered by 1, and the other x is powered by 1. So altogether, that's a polynomial powered by 4. And the number in front of it is positive, so the shape of the graph would be going upwards. The zeros are 2. Y-intercept, well, that's when x is equal to 0. Let's see, so I'm going to plug in x is equal to 0. That's 0 minus 2 squared. Then we have 0 plus 1, and then we have 0 minus 3. That's negative 2 squared is 4 times 1 times negative 3, or altogether the y-intercept is negative 12. In ordered pair, it's going to be 0, negative 12. Now I won't be able to graph very pretty that way because my graph only goes to negative 8, so I'll try to put like negative 12 right here. So the graph is going to start from above, go to the zeros are negative 1, 2, and 3. So it's going to start from above. At negative 1, it crosses the axis. It goes through negative 12, and then flips the direction and goes towards -2. So at -1 we'll have crossing. At -2 the graph is gonna touch and flip around, does something else, and we'll go back to, why did I say negative? It's +2. And then it's gonna cross to 3 again. So I don't know how big that graph is, but that's pretty much how it's gonna look. See if I can make it a little bit prettier. So start goes from -2, go through -2 to -1, then flips, goes to -2, flips, goes to 3. Where those ups and downs happen, we don't know. We learned that in calculus. Find all the zeros of the function and factor the function into linear factors, given that x is equal to 1 is a 0. Well, that's very helpful. We may use synthetic division to reduce the power. If one of the zeros is 1, then make that synthetic division table. Bring the 2 down. 1 times 2 is 2. 2 times 2 plus -3 is -1. Multiply -1. Add -6. Multiply -6. 6 minus 6 is 0. Oh, that's great. That means we were able to factor this polynomial too. Since 1 is the 0, x minus 1 is a factor. And we were able to reduce the power from x to the 3 to x to the 2nd to x squared minus x minus 6. Now we may or may not be able to factor this expression. I will use the quadratic formula to find the other 2 zeros, just in case, to demonstrate how to do so. The quadratic equation says x is equal to -b, so a is equal to 2, b is equal to -1, and c is equal to -6. So I'm going to put -b plus or minus square root b squared minus 4ac all over 2a. I'm plugging in this equation. X is equal to -b, so -1 plus or minus square root of -1 squared minus 4 times a times c all over 2a. Let's calculate. -1 is +1 plus or minus square root. -1 squared is 1. -4 times 2 is -8 times -6 is +48. Well, that's nice. There is a exact solution, so that means I might have been able to factor it out. X is equal to 1 plus or minus square root of 49 over 4. That means x plus or minus, x is equal to 1 plus or minus 7 over 4. One of the solutions getting with plus, which is 8 divided by 4 is 2, and the other solution getting with the minus. And that's -6 fourths simplifies to -3/5. So 2 solutions. Or actually 3 solutions altogether. Now the question, they want me to factor them all. So this polynomial factors to x minus 1. With the 2, the factor would be x minus 2. And with the -3/2, the factor would be x minus 3/2, which means minus -3/2, which means 3/2. And notice that There is that a, which will cancel that 2 at the denominator because we don't have any fractions. If we want to visualize that better, I can continue doing synthetic division for this 2x squared minus x minus 6, which is 2 minus 1 minus 6 divided by 2. The solution would be 2 times 2 is 4, 4 minus 1 is 3, 2 times 3 is 6, 0. See how this factor here become 2x plus 3 instead of being with the fractions. So that's x minus 1, x minus 2. Just distribute that 2 to this last factor, 2x plus 3. Either one of those two is good solution.